Here's a quick tutorial video for how to make molecular dynamic simulations using the piece of software known as Chimera. So the first thing you'll want to do is to download Chimera. You can go to UCSF Chimera, C-H-I-M-E-R-A, and then download. So if you search for that, the first link that'll come up is download UCSF Chimera. You can click on that, and they have different versions, whether you're using Microsoft, Windows, Mac OS, or Linux. And so you can click on those, you'll download Chimera. I'm going to assume that you've done that already before you move on to the rest of this video. So once you have Chimera, you can open it up. So I've already downloaded it. And here, this is what the landing page looks like for Chimera. What we need to do is we need to import the structure of a chemical into Chimera. And to do that, we can get that from databases that have been created by the government, funded by federal money. Databases that have lists of different information about chemicals. We're going to use PubChem. Let's pull up a molecule that's been in the news recently, remdesivir, that's been mentioned as a possible treatment for COVID. So you can take that, and we're going to search for PubChem. PubChem is a database that keeps information about a whole bunch of different molecules in it. And what we need is the PubChem CID. This identifying number, the CID there, that is going to be recognized by Chimera, and it will allow us to import this molecule into Chimera from this government database. So once you have that ID, I'm going to copy that here. Once you have that, we can go over to Chimera, click on File, and we're going to fetch by ID, that ID that we just got from PubChem. Now when you open this up, it may not have PubChem chosen automatically. This is a list of different databases that have information on a whole bunch of different types of molecules. So for example, PDB is the protein data bank. It has thousands and thousands of the three-dimensional information about different proteins that people have deciphered the structure over, or the structure for. For these small molecules though, we're going to use PubChem, like we've seen already, and I'm going to paste that ID into that box here. And then I'm just going to hit enter. When I do that, the Chimera imports the information, the three-dimensional information about that molecule that people have saved in that database. It imports it into Chimera. And so you get a three-dimensional picture of what this molecule looks like. It's pretty big. Now, there are different ways you can visualize this. You can visualize this using this Actions tab at the top. So if you go there, if you go to Atoms and Bonds, you can see this in many different ways. For example, you can see the ball and stick model. These ball and stick models, or wire models, so atoms, bonds, you go to wire, they give you a sense of the angles of the bonds and overall shapes and spaces in between parts of the molecule. One way I really like to visualize molecules is as spheres, so you can see the sort of van der Waals spheres. In general, how far out the clouds of electrons go around the nucleus. And so you can go to that atoms bonds, click on spheres, and that will give you this molecule right here. You can sort of now, with this structure, you can start to see connections between the sort of shapes of these molecules and what you might see, you know, the blobs you might see under a microscope. Of course, this molecule is much too small to see under a microscope. But for proteins and things, you could see how these types of blobs could be moving around in living things. So I'm going to change the coloring for this a little bit. Right now I'm going to go to Actions, Color, and I'm going to have the atoms labeled by element. And so this goes back to that classic system where gray represents carbon, white represents hydrogen, red represents oxygen, and blue represents nitrogen. And so you get a sense of what that molecule looks like in 3 dimensions. Now this is a flash frozen picture of this molecule. This is to the real molecule, sort of like a taxidermy animal is to a real animal. The molecule vibrates all the time. These bonds are vibrating. Single bonds are rotating. The molecule is tumbling and twisting and turning in space. And so we can try to get a better visual for what happens to this molecule by doing what's called a molecular dynamics simulation. To do that in Chimera, you'll want to go to Tools. You'll have a drop-down menu. You'll go to MD, that stands for Molecular Dynamics, or Ensemble Analysis, and you'll go to this Molecular Dynamics simulation here. When you click on that, a bunch of tables come up. Now, right now, this is a glitch I find happens sometimes on my screen. If you just have black, if you click on this, it'll populate. There's a lot of different things you can play with here. Right now, I just want to run a simple molecular dynamics simulation. And so I'm just going to do the basic thing. The one thing you have to adjust are the parameters. So you can leave this prep structure, salvation, constraints, etc. You can leave that as it is. Let's go to run parameters. There are two things you have to adjust here that I've had to adjust in order to save my molecular dynamics simulations. And those things are things you have to go to settings for. Instead of minimization, we're going to go first to equilibrium and then to production. So first equilibrium, or equilibration, sorry. The output trajectory files are the ones that I found I have to change. If I don't change them, it doesn't allow me to save or produce the file. So I keep the name exactly as it is, just in front of that dot, I add a 1. And this is giving this a new place to be saved on my computer. Usually it saves on the desktop, these different files. So before that last dot in this name, I put a 1. After you do that to equilibration, you can go to production. We're going to do the same thing. We're going to give a new place for this to be saved, a 1, right before that dot. Now I'm doing 1 for this molecule. If I were to do a second molecule, I change that 1 to a 2. If I do a third molecule, I change it to a 3. And so you can't replicate these output trajectory files once you use them. So once you have a place where these output trajectory files can be saved, in other words, once you add that number right before the dot to make this a new trajectory, you can hit run. It'll ask you about a lot of different things, but to do just a basic molecular simulation, you don't have to adjust any of this. You can use the default settings. So you press OK, use the default settings, press OK, use the default settings, press OK. It runs the simulation, and once the simulation has run, a new little box pops up. That box is going to allow you to play the simulation that you made. So let me put this little box to the left. We'll click on this, so this is taking up our screen. Here's our molecule again. And I'm going to take this is the sort of video here. I'm going to take this button here, I'm going to move it to the beginning, and now we can press play. And this is what remdesivir would look like as it's moving around as a dynamic thing at room temperature. Of course, this is much slower than the way it moves at room temperature. Each of these bonds would vibrate 10 trillion times approximately per second at room temperature. But this gives you some idea of how the molecule can wiggle around and change and be a living, breathing thing at room temperature. There is one other way, one nice thing you can do with this, and one other thing you can do, and that's it's nice to have this sort of rotate. So let's talk about how you can rotate so that you get a sense of its three-dimensionality as it's wiggling around. To do that, I like to use, you can go to Tools, you can go to General Controls, and you'll have the command line. This is going to open up a little command area at the bottom here, and you can tell this molecule to do different things. So what we can do, for example, is we can ask the molecule to rotate along the y-axis, and we can tell it how fast to do that. For example, let me put just 1 there. And so if we do that, oops, sorry, not rotate, but roll. If we do that, you can see that as this molecule is moving around, it's also rotating or rolling around that y-axis. And to make it roll faster, you can make this number bigger. And to make it roll in the other direction, or to stop it, slow it down, you can make it smaller and get it to roll in the other way. There are a bunch of different tricks that you can do to do this, but this at least would get you set up to at least create something like a GIF, which is a smaller file that you could save or that you can include in different documents. Otherwise, you can do screen recording to just get this video, and then you can include that in other videos too. Chimera has a nice way to cite them, and you can search Chimera citation. The value of those citations is they show the value of this program, the software, is government funded. The people who create this will only be able to keep adding to this and updating this if they continue to receive government funding. And one of the biggest ways you can get them, you can increase the significance of their work and their argument to get more government funding is to include a correct citation. So you can Google Chimera cite, and they'll have the citation you can copy and paste.